Hey everyone, this is the lesson on finding the area of triangles and trapezoids. Before we start, let's go over some basic vocabulary words. There are three basic triangles that we will be exploring in 6th grade. They include equilateral triangles, right triangles, and isosceles triangles. Equilateral triangles are where all three angles and all three sides are congruent. Right angles have a 90-degree angle located in them, and an isosceles triangle has a pair of congruent angles of congruent sides. Important to note that the angle measurement in all triangles, no matter what kind they are, equal 180 degrees. All triangles have a way of finding area that involves special types of quadrilaterals. There is a relationship between special types of quadrilaterals and triangles. So if you forget how to find the area of a triangle, if you remember this, you'll be able to figure it out. These apply to squares, rhombuses, rectangles, and parallelograms. If you take each of these shapes and draw a diagonal, two triangles are created, as demonstrated by the red lines that you see. As you learned years ago, the area is the inside of a two-dimensional shape, and the arrows here point to the area of the square, the parallelogram, and the rectangle. The method for calculating the area of these shapes is multiplying length times width. In this one, which is drawn to scale, this is 6 units long by 3 units wide. 6 times 3 is 18, so the area of the rectangle is 18 units squared. This can also be shown as base times height, as demonstrated in this parallelogram, which is 3 units tall by 5 units long, giving us an area of 15 units squared. Since the area of these special quadrilaterals is base times height, taking half of that gives us the area of a triangle, which is really cool. If the rhombus below has an area of 16 units squared because it's 4 units tall by 4 units wide, 4 times 4 is 16. Well, half of that is 8. Same thing applies to the parallelogram. That one is 6 units long by 4 units tall, giving an area of the parallelogram of 24 units squared, and the triangles inside would each be 12 units squared. Because triangles are half of a rectangle, a square, a quadrilateral, or parallelogram, you can derive a formula or method for calculating it. This would be the base times height divided by 2. In this triangle example, that's 4 units wide by 7 units tall. If you plug in the numbers, 7 times 4 is then 28, and 28 divided by 2 is 14 units squared. These shapes are drawn to scale. Calculate the area of these of these triangles, and then the next slide will give you the answers. Pause until you're done. As you can see, the triangle all the way on the left is 4 units squared. The middle one is 8 units squared, and the one on the right is 6 units squared. These came from having the one on the left, for example, was 2 units tall by 4 units wide. 2 times 4 is 8, divided by 2 is 4. In the middle one, it's 4 units tall by 4, the base is 4, the height is 4. 4 times 4 is 16, half of that is 8. And the one on the right, that is 2 units tall by 6 units long, or however you want to say it. 6 times 2 is 12, half of that is 6. Now complete these questions. Pause, and then you can check your answers on the next slide. Here are the answers to the previous questions. Now let's move to trapezoids. Trapezoids are a special type of quadrilateral that have one pair of parallel sides. The two we're going to focus on are called right trapezoids and isosceles trapezoids. Two methods exist for finding the area of a trapezoid. One is breaking the trapezoid into smaller shapes. If you look at both of these, what I did, and with the right trapezoid on the left, was break it up into a triangle and a rectangle. If you find the area of the smaller shapes and then add them together, you will get the area of that trapezoid. The inside rectangle on example 1 is 12 units squared. That triangle is 8, giving us a total area of 20. On the right-hand side, there are two smaller triangles and a rectangle. The rectangle is worth 12. Each smaller triangle is worth 4. 12 plus 4 plus 4 gives us 20 units squared. The second method, or formula, for finding the area is unique in that it uses an average of the lengths to change the shape into a rectangle. The formula looks like this. And it looks kind of complicated, but it really isn't. B1 and B2 refer to the two bases. You're adding those together and then dividing them by 2, which gives you an average length. Then you multiply it by its height, and you get the trapezoid. This is why it works. Look here. B1 is worth 4 units. B2 is 8. The height is 4. Look at the rectangle circumscribed over top. This triangle on the right, if you flip it and put it on the left, you create a rectangle. The average length of 4 plus 8 is 6, and then 6 times 4 gives us 24 units squared. And just using the formula, it looks like 4 plus 8 divided by 2 times 4, which is then 12 divided by 2 times 4, which equals 6 times 4, which equals 24 units squared. Now try these questions. They are not to scale. Work this out. Well, first, pause it, work it out, and check your answers on the next slide. And here are your answers. Trapezoid on the left is 132 units squared. The next one is 280 units squared. The third one is 18 units squared. And the last one is 30 units squared. Replay this as often as you need to, and have a great day.